And now it looks like your vehicle is underway. It's submerged and departed from the dock. So what's your sub's name?
So our sub name is Marlin.
Marlin. Fantastic. Any meaning to it, or just a majestic animal that you want to honor?
It is a majestic animal. It's a beautiful fish.
Yeah.
It's a beautiful fish that we decided to name our sub after.
Okay. And it is through the gate, gone through the AVBotz gate, as far as I could see. It is now doing its pirouette and spinning for those style points.
Yep. As expected.
And I know we keep saying it, but big thank you to the Nywick Pacific Dive Locker and all of the divers that have supported this event from just across the military. And we can see them now pointing the direction of the sub, so we can see where Marlin is headed towards. It looks like he's headed perhaps to that buoy to maybe interact with these glyphs. Coming up on the screen right now. So now, what's the vehicle's approach to this challenge?
It's mainly just we decided we weren't going to hit all of them, because I know that does give bonus points. We were just going to hit the two that we are assigned.
Very cool. So you should be going after the top right and the bottom left. Very cool. And so you're using some type of machine learning on this. Did I hear you throw out YOLO?
Yeah, I think we're using YOLO V8.
Okay, V8, all right, cutting edge. Now, have you seen any, and we see one contact there. Now, have you seen, sometimes when you're on, to quote the great Linus Sebastian of Linus Tech Tips, when you're on the cutting edge, the problem is you get cut. Right, so with working with YOLO V8, which is the latest and greatest, have you encountered any difficulties there with integration?
Actually, we haven't. It's actually worked very well with us because we actually are not required to use a GPU for our processing. We actually only need to use a CPU.
So you're running YOLO on your CPU, and how many frames per second are you able to get?
I'm not sure, but according to the software team, it works really well.
Very cool, very cool. Now, what type of hardware are you using on your boat? What CPU is that running on?
So we are using a Jetson.
Yeah, cool. Which one?
Orin.
Orin, nice, very nice, fantastic module that Orin has. And so now that we have completed the buoy challenge, so where's the vehicle going to next?
It looks like it's going to be going to our torpedo board.
Very cool. And now that is up on the screen. And so will you shoot one torpedo or two torpedoes?
We're looking to shoot 2 torpedoes today.
Very cool. Nice. Going to go for both.
Yep.
Very cool. So that torpedo, their teams have had a couple of different solutions to firing that shape. Now, how does your team go about doing it?
Yeah, so we decided we were going to 3D print a torpedo mount. It's going to basically has a spring, so 2 springs for our 2 torpedoes, and then it has a latch that's able to release that spring, or release the torpedo being shot by the spring.
Very nice. Nice mechanical mechanism and a just actuated latch. That'll do the trick.
Yep.
So I've been kind of asking a lot of folks behind the scenes, and I don't think that we've recorded this, but you guys were kind of the inspiration to the question, which is, and I'm seeing it again and again with the finals teams, which is there is, if you were to graph how many advanced components and algorithms there are in the vehicle and what the performance of that system is, I think that you need to be pretty sophisticated to do well, but I think that you hit a certain point where if you have too many advanced things, you start seeing not just diminishing returns, but just worse returns. because now there's too much to keep track of. And so then there's probably a few on the top end that, you know, you've got a bunch of good stuff and it's doing well, but what do you think about the philosophy of keeping it simple and not overextending?
I think it's an amazing philosophy. That really hit us hard this year, especially during the first few weeks. That was mainly one of our issues. We were having some problems. We were using a really advanced signal protocol that we just really didn't think we could. We thought we could pull it off, but it was very difficult to debug.
Yeah.
And we switched to a more simple protocol, and it seemed to work well. And that's what we're using now.
Team's getting fired up right now. I think that you might have just successfully launched a torpedo and maybe even through the bottom Stargate. Now let's see if we can see it go through the top one. And there we go. We can see the torpedo on the backside indicating that it has gone through the closed Stargate. And look at them dropping down after successful launch. Fantastic, and congratulations on that piece.
Thank you.
So now, so you said that there was this protocol that you were debugging. What was it?
So it was the CAN protocol.
The CAN, yeah.
And I do know that it is an industry-leading type of signal protocol, but it's just really difficult for us to debug. And I think PWM ended up working out well for us. It's very simple. We can just probe it with an oscilloscope, and we can just basically get what we need from the oscilloscope and easy debugging. I
am a big fan of open source, just open communications, and it's kind of along the lines of what you're saying, that the more introspection that you can have to what's going on, just the more knowledge that you can have about how the data is being sent, it allows you to create those robust, reliable solutions, and it sounds like that's what you guys lean towards this year.
Mm-hmm.
Cool. So now, are you guys going to... Kill! Okay. The team is now informing that we're going to kill the robot, and I guess we'll go back to the dock and go after another run. And that was, it seemed like a great run.